Hi, I'm Miss Roger, and welcome to Core Concepts in Algebra 2. Today's lesson is going to be on rewriting equations in slope-intercept form. The Massachusetts curriculum frameworks are tied to this lesson, specifically FIF, Functions Interpreting Functions, number 8, and FBF, Building Functions, number 1, and ACED, Creating Equations, number 1. The lesson objectives are to write equations in slope-intercept form when given the slope and the y-intercept, an equation in standard form, the slope and a point on the line, 2 points on the line, a point in a line parallel, and a point in a line perpendicular. Let's take a look at our first problem. Write the slope-intercept form of the equation of each line when given the slope and the y-intercept. So let's first identify what our slope-intercept form is. Slope-intercept form is y equals mx plus b. Our m is going to be our slope, and our b is our y-intercept. We can also think about our slope as rise over run. So, let's substitute 1/2 in for the slope and 4 in for the y-intercept. This is slope-intercept form when given a slope of 1/2 and a y-intercept of 4. Let's take a look at problem number 2. Write the slope-intercept form of the equation of each line. 5x plus 7y equals 56. This problem is not in slope-intercept form, so our task is to put it in that form. This is one way of helping us do this. Ultimately, we want to bring 5x to the other side, and we want to have a value of 1 in front of y. So let's subtract 5x to the other side. In order to get y alone, we want to divide everything by 7. 7 divided by 7 is going to give us the 1 that we're looking for. Remember, whatever you do to one side of the equation, you must do to the other. So we're going to get y equals 8 minus 5 over 7x. We're almost done. We need to make sure to put it in slope-intercept form where we have mx plus b in that order. So 5x plus 7y equals 56 is now in slope-intercept form, y equals negative 5 over 7x plus 8. Let's take a look at problem number 3. Write the slope-intercept form of the equation of the line through the given point with the given slope. So here, they give us an xy ordered pair. And they give us our slope, which is negative 2. That's our m value. So what we're going to do is we're going to substitute x and y into our equation as well as our m and solve for b. When substituting, make sure to use parentheses. Three times negative 2 is negative 6. To get b alone, we want to bring negative 6 to the other side of the equation. In order to do that, we're going to add 6. So here, our b value equals 5. We're going to substitute this in and have our slope-intercept form. So if we're going through a point 3, negative 1 with a slope of negative 2, our slope-intercept form is going to be y equals negative 2x plus 5. Let's take a look at problem number 4. Write the slope-intercept form of the equation of the line through the given points. So for this problem, they give us 2 points that are on the line, and they want us to find the line in slope-intercept form. So let's denote our points with x and y. The first thing that we're going to want to do is find the slope of this line. Once we have the slope, we can use one of the points and relate this back to the problem that we just solved. There's a formula to find the slope. Slope is rise over run. It's also y2 minus y1 all over x2 minus x1. This will help us arrive at what the slope is for this equation. So I'm going to denote these points with sub 1s and sub 2s. So these are both going to be with sub 1s, and these are both going to have sub 2s. Now I'm going to fill these in and find the slope. Two minus negative 4 is going to be 2 plus 4, which is 6. Negative 5 minus 0 is negative 5. So here I have a slope of negative 6 over 5. Remember, you want to leave your answers for the slope as improper fractions because you want to be able to clearly see a rise and a run. Now, I have a slope, and I can use either of these 2 points on the line to find slope-intercept form. It doesn't matter which one you choose. So let's select the first one. So we have our slope, and now it's going through this xy ordered pair. Let's fill in our x and y. X is 0 and y is negative 4. Our m is negative 6/5. Let's solve for b. Negative 6/5 times 0 is 0. So b is negative 4. Now we have our slope-intercept form equation. The slope-intercept form equation is y equals negative 6 over 5x minus 4 if we're going through the point 0, negative 4 and negative 5, 2. Let's take a look at number 5. Write the slope-intercept form of the equation of the line described. So we're going through the point negative 2, negative 5, and it's parallel to the line y equals 4x minus 2. What do we know about parallel lines? Parallel lines have the same slope. So this indicates to us that our slope is going to be 4. We know that because this equation is in slope-intercept form, y equals mx plus b, and our m is our value of 4. So this is similar to our last problem. This is x, this is y, and we have a slope. We're going to solve for b. Y is negative 5, m is 4, x is negative 2, and b is what we're looking for. Remember, b is the y-intercept. We want to bring negative 8 to the other side, so we do that by adding 8 to both sides. For this problem, b equals 3. We have our slope, which is our value of 4, and we have our y-intercept, which is our b, our value of 3, so we have slope-intercept form. Slope-intercept form for this problem is y equals 4x plus 3. This is going to be parallel to the line y equals 4x minus 2, and it goes through the point -2, -5. Let's take a look at number 6. Write the slope-intercept form of the equation of the line described. It goes through the point -5, 0, and it's perpendicular to y equals -5 over 4x. Let's think about what perpendicular lines, what that means. Perpendicular lines typically form something that looks like this. So if we were in geometry, we'd have right angle marks. Algebraically, what that's going to mean is that we have negative reciprocal slopes. So if this line has a slope of -5/4, a line that's perpendicular will have a slope that's the negative reciprocal, which means I can flip the numerator and the denominator to be 4/5, and if it's negative, I make it positive, and if it's positive, I make it negative. So the slope, that's a negative reciprocal slope of -5/4 is 4/5. We also have our xy ordered pair. We're ready to solve. We have our slope and our xy ordered pair. Let's find slope-intercept form. Let's substitute our x, our y, and our m values to solve for b. Typically, when I have a fraction as my slope, I like to put my x value over 1, so I can clearly see what's going on when I need to multiply. Remember, when you multiply fractions, you multiply the two numerators and the two denominators. 5 times 4 is -20, and 5 times 1 is 5. I can cross cancel, or I can reduce after. -20 divided by 5 is going to give me -4. 5 goes into 5 once. 5 goes into -20, -4 times. I need to bring -4 to the other side. So I'm going to add 4 to both sides. B must equal 4. I now have slope-intercept form. Y equals 4/5 x plus 4 is the equation to the line in slope-intercept form that goes through the point -5, 0 and is perpendicular to y equals -5 over 4x. Remember, with this problem, there's technically a +0 there as the y-intercept. Don't be confused by that. What are the major components of an equation in slope-intercept form? What is the purpose of putting an equation into slope-intercept form? And what strategies can we use to put an equation into slope-intercept form when given various information? Start to think about these questions tonight, and we'll discuss them tomorrow during class. After learning about how to put equations into slope-intercept form, try these. Write the slope-intercept form of an equation of a line from the given information. The first one indicates the slope and the y-intercept. The second one is in standard form. The third one indicates a point that the line goes through in the slope. The fourth one indicates the 2 points that the line goes through. The fifth one gives you a point that the line goes through in a line parallel. And the sixth one gives you a point that the line goes through in a line perpendicular. We'll discuss these tomorrow. Thanks. See you next time.